Alright, hello everyone. My name is ISKANDAR bin YUSRI. I'm from KIB 190033. Alright, so first of all, today I'm going to show you how to draw the halfway rectifier circuit with filter and the capacitor. Alright, so let's draw it first.
Alright, so let's draw it first. I'm going to put the ideal transformer. I'm going to put the resistor. And we're going to put the capacitor. Alright, and then and don't forget the semiconductors. Alright, and then we're going to connect all of these components together in the first loop. This one will be connected to the second loop. Alright, connect the capacitor too. Okay, and then we're going to put the ground meter here. From 1 and alright, and then I'm going to put the meter. This for the BF1, this for the BF2, and this is for the BF3. Disconnect this, correct? Alright.
Okay, so for the capacitor I'm using is varied from the 80 μ farad, 8 μ farad, and also 800 μ farad. So we're going to test it out starting from the 8 μ, and then we're going using a ratio of 1:2, so ratio of 1:2, and we're going to change the unit step to the sinusoidal step. So the ratio should be 1:2. Alright, we're going to run the transient analysis, 100 meter for the display, and we will get this data. Alright, so this is supposed to be my 8 μ, and when I increase the value of the my capacitor to the 80 μ farad, you can see it's getting the wave here is getting a little bit less stable, and then when I increase it another more to the 800 μ farad, I'm going to get a linear wave of this data. So what I'm going to do is I'm going to find the value of the V peak. So I'm going to pick the 80 μ, which is the most easiest way to read the peak value. So I'm going to run the analysis transient analysis. Alright, so this I'm going to mark at this point, find the highest peak value. So it should be 1.34, is it? Alright, and then the value of 1.34, I'm going to use it in the half wave filter calculations. So to find the average VDC, I'm going to use a formula of V peak over pi. So 1.34 over pi, I should get 0.427 voltage. Meanwhile, for the root mean square output voltage, for my VRMS, the formula is between V peak over 2. So my V peak is 1.34 over 2, I should get 0.67. And then for my ripple factor, this is the formula of my ripple factor, and when I calculate all of this, I should get 1.209 for my ripple factor. Alright, hello. So the next part, I'm going to draw the full wave center tap rectifier. So first I'm going to
and then the ideal transformer is center tap. And then we're going to put the resistor. And then the capacitor. And don't forget the semiconductor too. Okay, so the next part I'm going to get all of these components together. Alright, then we're going to put the base switch here, and another one over here. And for the sources, for the meter, for the BF1, I'm going to put in between these voltage right here. And for the BF2, it should be over here. Right, and finally for my BF3, I should put in between the semiconductor and also between the resistor.
Alright, the value I'm using is 8 μ. Okay, so I'm going next going to change the unit step into the sinusoidal step. Okay, press the OK button. The ratio I'm using is 1:2 at first. Might change later. Right, then we're just going to run the transient analysis. Okay, so this is my data for the 8 μ farad. Okay, this is my data for the 8 mil farad, which means I get a V peak is 423.71 meter. And this is my data for the 80 mil farad if I increase the capacitor value. And this is my value for the 800 mil. So which means in this between three result, I think I'm using the capacitor of 8 mil farad, which means I can get the more accurate for the voltage peak. So after I get this value, I'm going to calculate it. So by using the formula of average output voltage, I should get my VDC is equal to 269.74 volt. And for my VRMS, I should get 299.61 volt. And for the ripple factor, by using the formula, I should get 0.48. Okay, next for the ratio 1.2, I'm going to find the ratio for the 1.4. Okay, by using this, I'm going to change this to 4. Okay, and then analysis, transition analysis. Okay, so this is my okay. This is my result for the transition analysis 4. This is for the 8 ratio of 8 mil farad for the capacitor. So I'm going to find the peak value of I should get 1.37. No, I think 1.38. 1.38 should be my highest peak of the value. I'm using 8 mil farad also this time because I think if we increase the capacitor value, the wave will be linear, so it's hard to find the peak of the voltage. Okay, so by recording this data for the 1.4 ratio, my average output voltage should be 0.88 volt. And for my VRMS should be 0.98 volt. And for my ripple factor, by using the calculation, and for the formula, I should get 0.50. Okay, for the test circuit, we're going to draw the full wave bridge rectifier circuit. So this is my my circuit for the full wave bridge rectifier. I don't have enough time because we know that the time limit is under 10 minutes. So I'll just skip the drawing phase. Okay, so this basically is my my drawing. So this is the semiconductor value I'm using, and okay, I'm going to change for the ratio of 1:2. And the value of my capacitor I should be using is varied to 8, 80, and 800 mil. So first I'm going to use the 8 mil. Press the OK button. And then we're going to run the analysis. But before that, we need to check, is it in sinusoidal or not? Is it in sine wave? All right. Okay, and then we're going to run a transition analysis. 100 meter for the display. All right, so this is my transition analysis for reading the AC wave of the full wave bridge rectifier circuit. So after marking this, I should get my value. The peak value is 794.87 meter. Right. By changing the value of the capacitor from 8 to 80, so I should get this one. Look at the data of the wave. It's getting a little bit linear, so it's really hard to read the peak. And for the 800 capacitor, it becomes very linearity, which means I really cannot read the value of the peak. So I should take the reading of the in the 8 capacitor value. So I should put it in my calculation by using the formula of average output voltage. Likewise, my VDC should get 506.03 voltage. Meanwhile, for my VRMS, I should get 562.06 voltage. For the ripple factor, by using the calculation of the value that I got for VRMS and also the V average output voltage, I should get 0.48. All right. So moving on to the ratio of 1:4. So I'm going to change this transformer to 4, and then this value of 8 mil. And then we're going to run the analysis, transition analysis. Okay. So this is my graph for the ratio of 1:4 bridge. So check it. Okay, this is my result. So after finding the peak value, I should get my peak value is 2.7. Meanwhile, if I change the capacitor value to the 80, it will be a little bit hard again to read the peak. And for my 800 mil, we can see that the wave is very linear, like it's very hard to read the peak. So we should take the value of 8 new capacitor as we to need the to take the peak reading, which is the voltage peak. Okay, by taking this, we put into the calculation of 1.4. So for my average output voltage, I should get 1.72 volt. And for my VRMS, I should get 1.91 volt. Meanwhile, for my ripple factor, by using this calculation and this formula, using the value of VRMS and also the V output voltage, I should get 0.48. Alright, that's all for me. Thank you very much.